So today we're exploring Tesla's Optimus 2, a landmark in robotic evolution. We'll discuss its critical features, industry impact, and large language models, LLMs, integration. Okay, one of the most striking aspects of Tesla's Optimus 2 is its autonomy. In previous iterations, such as Tesla Optimus Generation 1, the robot was often tethered to a wall by a cable. This raised concerns about its capacity to operate independently. However, Optimus 2 has addressed this issue by showcasing its ability to walk alone and operate autonomously. During the development phase of humanoid robots, tethering is a common practice to prevent damage. Robots are sensitive and expensive technology. Protecting them from unintended falls and impacts is essential. Optimus 2's ability to operate without external support or guidance demonstrates significant progress in balance control. Humanoid robots like Optimus 2 are known for their impressive capabilities, but come with a hefty price tag, often costing hundreds of thousands. This high cost is primarily due to the complexity of the technology involved, the precision required in their design and manufacturing, and the extensive research and development efforts invested in creating them. An autonomous robot that can operate without external support showcases technological progress and reduces the risk of costly damage, making it a valuable development. Another impressive aspect of Tesla's Optimus 2 is its speed and dexterity. When watching the demonstration, it's evident that this robot operates in real time with exceptional speed. This is a departure from the norm in robot demonstrations, where movements are often slowed to make them appear more precise. Optimus 2's ability to move swiftly and precisely is a testament to its advanced control systems. The robot is significantly lighter, weighing 10 kilograms, 22 pounds, less than the earlier version. It also boasts a 30% increase in walking speed, indicating improved leg strength and coordination. While Optimus 2's autonomous capabilities are impressive, there's a brief mention of VR teleoperation mode in the original content. VR teleoperation is a method of controlling robots using virtual reality headsets. This technology allows for exact control of robots, offering a level of dexterity and accuracy that is challenging to achieve through traditional methods. The mention of VR teleoperation mode in the context of Optimus 2 raises an intriguing question. Did Tesla use this mode during the demonstration? If not, it would indicate that the robot's movements were entirely autonomous, which is a remarkable feat. However, if VR teleoperation was involved, it would highlight the level of control and precision that can be achieved with this technology. Optimus 2's exceptional speed and dexterity have significant implications for the future of robotics. Consider the impact on industries that require fast and precise automation, such as manufacturing and logistics. Robots that can match or exceed human speed and accuracy have the potential to revolutionize these sectors, increasing efficiency and productivity. Moreover, speed and dexterity are crucial when robots need to respond quickly to dynamic environments, such as disaster response or medical applications. The ability to operate at real-time speeds opens up new possibilities for robots to assist in critical tasks, where rapid decision-making and action are essential. Picture an emergency situation where you've got only a few seconds to react, and there's this robot that, in that brief instant, has to consider millions of possible outcomes. Why did it make that particular choice? What led it to act in that way? Could it have done something different? In short, it's a sensitive issue. Another standout feature of Tesla's Optimus 2 is its ability to manipulate delicate objects with precision and care. The robot gently handles a fragile egg in the demonstration, placing it precisely in a designated spot. This level of delicacy and accuracy is a testament to the advanced control and sensor systems integrated into the robot. Comparing Optimus 2's performance in delicate object manipulation to other robots highlights Tesla's proficiency. While other robots may struggle with such tasks, Optimus 2 easily handles them. This capability has implications for applications ranging from managing delicate medical instruments to assisting with intricate assembly processes. In addition to its impressive functionality, Optimus 2 boasts a futuristic and sleek design. The aesthetics of the robot are noteworthy because they play a role in how the robot is perceived and accepted in various environments. A modern and aesthetically pleasing robot is more likely to be welcomed in public spaces, workplaces, and homes. The design of Optimus 2 aligns with Tesla's commitment to advancing technology and making it visually appealing and accessible. The speed at which Tesla's Optimus 2 has evolved is equally fascinating. We were introduced to Tesla's Optimus Generation 1 a few months ago, and now have the second generation. This rapid development underscores the dynamic nature of the robotics industry. However, Tesla is not alone in this endeavor. Other companies are also entering the race to develop humanoid robots. One recent example is Kepler, a company that released a robot strikingly similar to Tesla's Optimus 2. This competition among companies to create humanoid robots reflects this technology's growing interest and potential. The emergence of multiple companies striving to develop their versions of humanoid robots is a testament to the competitive nature of the robotics industry. It's a race to create the most advanced and capable robots, and this competition can drive innovation and push the boundaries of what is possible. As companies like Tesla and Kepler continue to invest in humanoid robots, we expect to see exciting breakthroughs. These breakthroughs may lead to robots that can perform various tasks, from assisting with daily chores to contributing to complex industrial processes. The potential applications of humanoid robots are vast and diverse. These robots could transform numerous industries, from healthcare and manufacturing to entertainment and beyond. Let's explore some of the sectors where humanoid robots could make a significant impact. 1. Healthcare. Humanoid robots with advanced mobility and manipulation capabilities could assist healthcare professionals in patient care, surgery, and rehabilitation tasks. They could also provide companionship and support for patients, especially in aging populations. 2. Manufacturing. The manufacturing industry benefits immensely from robots that can match or surpass human speed and precision. These robots could handle intricate assembly tasks, quality control, and logistics increasingly efficiently and reducing production costs. 3. Search and rescue. In disaster-stricken areas, humanoid robots equipped with advanced sensors and mobility could navigate complex environments to locate and assist survivors. They could play a crucial role in disaster response and recovery efforts. 4. Education and entertainment. Like Disney's new AI robots, humanoid robots could serve as interactive companions for children, aiding in early education and entertainment. Their ability to communicate and demonstrate concepts could make learning more engaging. By the way, if you haven't seen our video about Disney's new AI robots, you'll find a link to it in the description. Trust me, you don't want to miss those cutie puppy robots. 5. Retail and hospitality. Robots with social capabilities could be employed in retail stores and hospitality settings to assist customers, provide information, and enhance the overall customer experience. 6. Space exploration. Humanoid robots may find applications in space exploration, assisting astronauts with tasks on spacecraft or planetary surfaces. Their ability to operate in extreme environments could be invaluable. 7. Agriculture. Robots capable of manipulating delicate objects could be employed for fruit picking and handling fragile crops. This could increase agricultural efficiency and reduce labor requirements. 8. Construction. Humanoid robots with strength and precision could assist in construction projects, performing tasks such as bricklaying, welding, and heavy lifting. 9. Military and defense. In military applications, humanoid robots could be used for reconnaissance, logistics, and bomb disposal, reducing risks to human personnel. 10. Home assistance. As technology advances, humanoid robots can become valuable household companions, assisting with chores, security, and caregiving. Hey, just a quick break to say that if you find our efforts helpful, please consider subscribing to our channel. It's a great way to support us and stay informed about the latest AI news. And you know it already, it's free. Okay, so back to us. While we marvel at the physical capabilities of robots like Optimus 2, another aspect of robotics is equally transformative: integrating large language models, LLMs, into robotic systems. LLMs enable robots to understand and respond more nuancedly and context-awarely to human language. This enhanced interaction makes robots more intuitive and adaptable in various situations. For example, Google's Gemini LLMs. These models can process language, make sense of context, and carry out tasks based on natural language commands. For instance, they can identify objects, make decisions, and perform actions guided by language input. For more details, here is a video we made about Gemini. Check it out. It has everything you should know about Google's latest LLM. As LLMs become integrated into robots, the concept of multimodal AI comes into play. Multimodal AI refers to the ability of robots to process information from various sensory inputs, including text, speech, images, and more. This enables robots to have a more comprehensive understanding of their environment and interact with it effectively. In the mentioned video, we see how an AI model can identify objects and take actions based on language input. For example, it can recognize the color of an object and locate it in its environment. This showcases the potential for robots to use LLMs to enhance their perception and decision-making abilities. As we explore the advancements brought by Tesla's Optimus 2 and the integration of LLMs into robotics, it's clear we're on the cusp of a profound transformation in how robots interact with the world and with us. The combination of physical capabilities and advanced language understanding opens up new possibilities for robots to be valuable companions, collaborators, and problem solvers in our lives. However, as with any technology revolution, there are challenges to navigate. As we move forward, ethical considerations, privacy concerns, and the impact on the workforce must be addressed. The key lies in responsible development and thoughtful integration of these technologies. So, in conclusion, Tesla's Optimus 2 represents a significant leap in autonomous robotics with implications for various industries. And the integration of LLMs into robotic systems enhances their interaction with humans and their environment. The future of robotics is bright, but it must be guided by ethical and responsible development practices to ensure these transformative technologies benefit society. Congratulations on making it to the end of this exciting Tesla robot update. Before you go, let's keep the energy going. Leave us a Tesla in the comments to let us know that you watched the whole video. Smash that like button and subscribe to stay up to date. As a bonus, remember to dive into our end screen video for even more fascinating insights into AI's latest innovations. We sincerely appreciate your continued support. Stay ready because we'll be back soon with another electrifying update. Until next time, take care.